In this next video, I'm only going to be working on the left side of this page and doing the 3 odd exercises. We're going to determine where the location of the vertices and the foci are, the direction of the opening of each of these hyperbolas, as well as the asymptotes is something I'm going to add to this. I want to find the equations for their asymptotes. Let's get started. Number 1, the x is the positive squared variable, which means the direction it's going to open horizontally. The next thing is, where's the center? Our center is 0, 0. Even though it didn't ask us that, it helps us to find the vertices. The vertices are always on the transverse axis, in this case the x-axis. Square root of 81 is 9. I'm going to add and subtract 9 to the horizontal or x-coordinate. So our two vertices would be negative 9, 0 and positive 9, 0. The foci, let's add 81 and 4. Let's add them together. So a squared plus b squared, 81 plus 4 is 85. That equals c squared. C equals plus or minus square root of 85. 5 goes into 85 17 times. Not a perfect square. No perfect square factors that. So I want to add and subtract this to the x-coordinate of the center to make our two foci coordinates. So negative root 85 comma 0. Positive square root of 85 comma 0. So in about a minute we found the vertices, the foci, and the direction of the opening. The asymptotes. We'll have two asymptotes. Find the slopes. The change in y divided by the change in x. Square root 4 and divided by the square root of 81. That's 2/9. And double check, does this pass through 0, 0? Yes, the y-coordinate of the y-intercept would be 0. Have you been asking yourself this yet? What happens if the center isn't 0, 0? And how does that affect all of this and even that? Well, maybe the next one won't go through 0, 0. Well, actually, it looks like it does. So again, our center is 0, 0 this time. Let's determine which axis is our transverse axis. The y is the positive squared variable, so we have a vertical transverse axis. Our graph's going to open up and down, which means we're going to add and subtract to find the vertices. We're going to add and subtract to the y-coordinate. We're going to add and subtract the square root of 25, or 5 units, to find our vertices. 0, 5, 0, negative 5, like here and there. Our foci, let's add up 25 and 16. That's 41. So C equals plus or minus square root of 41. We're going to add that again to the y-coordinate of our center. So our foci is 0 plus, or 0 comma root 41, and 0 comma negative root 41. Let's take a look at the asymptotes. We know it has to pass through 0, 0. So let's take a look. The slope is the change in y divided by the change in x. Square root of 25 divided by the square root of 16, which is 4. So our asymptotes are y equals plus minus 5/4 x. Really simple because it goes through the origin 0, 0. That's about to change with question 5. With question 5, our center is written in a different formula, or actually our hyperbola is written in a different formula, but I am 100% confident that you know that the center of this hyperbola will be at -2, -8. What's the direction it opens up? Because the x is the first term that's positive, that's that positive squared term, we know that this is another horizontal transverse axis. It's going to open left and right. So if this is our center, -2, -8, what we're going to do is we're going to add and subtract 13 units to the x-coordinate of your center. What is 13 more than -2? 13 more than -2 is 11. What's 13 less than -2? -15, -8. These would be your two vertices. Let's find the two locations of the foci. 169 plus 4. C squared equals 173, and C equals plus or minus square root of 173. This does not have any perfect square factors. we would have to check things that are less than 13. The primes that are less than 13, 13 won't go in, 11 won't go in, 7 won't go in, 5 won't go in, 3 won't go in, and 2 won't go in. So we're going to add and subtract this to the x coordinate to find the location of our foci. That's one foci, -2 plus root 173, comma, -8. The other one is -2 minus root 173, -8. Okay, here's a game changer. Where's the location of the two asymptotes? Our asymptotes have to pass through the center here. So what we're going to do is we're going to build the equation like we did the last time by finding the slope, except I'm not going to rewrite this or write this in slope-intercept form. I'm going to use point-slope form. Let's determine the two slopes for the asymptotes. Change in y is 2. The change in x is 13. So our slopes are 2/13 and -2/13. The y coordinate of the center is -8. So I'm going to use the same expression that we have in our equation. Y plus 8 is equal to plus or minus 2/13, comma, not comma, times, parentheses, x plus 2. This will ensure that our line has the correct slope, change in y over change in x, and that it will pass through the center. These are the two equations for our asymptotes. They are totally acceptable. If you wanted to rewrite both of them and solve them for y and slope-intercept, that's totally up to you and is optional. I would accept these as the equation for our asymptotes. Let's move on to our last video, which is how are we going to graph it if it looks like this with the center not at 0, 0.